Hey guys, my name is Jonas Nicklas. I've actually been thinking about starting a support group for people who are obsessed with testing, but I'm afraid that I'll be the only one who shows up. When I first heard about the whole concept of automated software tests, I was like, oh my god, this sounds so boring. I had no idea how I was going to use this, and it just sounded like this completely boring process where you're just like testing everything to the nth degree all the time, and I didn't really get it at all. And it took me a really long time to understand that testing is really awesome. I pulled the plug on this side. I don't need the light, it's okay. All right, okay. Sorry. Am I good to continue? All right. Sure thing. There we go. Apparently I'm destroying the setup. All right, and we have light again. Cool. All right, so I have a question to you guys. Do you guys test your code? All right. Can we just like get a show of hands? Who here tests their code? All right, that's awesome. Who doesn't? Oh, a few people. I'm really here to talk to you guys today about not only testing your Ruby code, but also testing your JavaScript code. I'm guessing that most of you are going to be working in web development, and a lot of you are going to have a sizable amount of JavaScript code. And I'm also guessing that you are not testing it. Am I right? Who is testing JavaScript code? Couple of people. All right, decisively less than the people who test Ruby code. All right, so I'm just going to quickly go through why I think testing is awesome, because I think it's really important not to cargo cult. If you've never heard that expression, it means to just sort of, because someone famous or someone you respect says something, you just imitate them without reflecting over why you do it. And I think that's generally not a good thing to do. You really want to sort of lay out for yourself why you're doing the things you're doing. And I think we do testing for 3 reasons. For ease of refactoring, for improving the design of your code, and to prevent regressions. I'm just going to go through each one of these and just kind of quickly explain why I think they're important and why I think testing helps you in these areas. So if we look at refactoring, no one writes perfect code on the first try, and if they claim that they do, they're probably lying. I've worked with a lot of people over the years, and I've never met anyone who writes perfect code on the first try. And I don't know, maybe people like Kent Beck or something, maybe they do, but I wouldn't think so. So the whole idea of refactoring is to make changes without affecting functionality, so that because you don't write perfect code on the first try, you need to be able to change your code. You need to be able to change your code easily, and you need those changes not to affect the functionality of the code. So how do you know? How do you know if the changes you made actually affected the functionality or not? On the surface, this seems a fairly simple problem. You just check if the code still works the same. But if you do this manually, it quickly becomes very tiresome. And the fact that it's tiresome makes you less likely to do it, and eventually you will have changes in your code that you don't know about. The functionality will have changed, and stuff will break, and this is what we call bugs, right? So if you automate the whole thing, you just write it once and you never think about it again. So think about the following scenario, just creating a to-do item in an application. It's a simple thing. You open a browser, navigate to a page, fill in the description, press create, check that it was created correctly. Sounds simple enough. Now do that 1,000 times. and it quickly becomes incredibly boring. And we do this every day. Like we just sit there clicking through our browsers and checking that stuff works. And the more we can automate this, the more our jobs actually become fun, because we can focus on the important stuff. And this is really the cool thing about TDD and testing in general that I realized after a while, is that testing is fun because it removes this incredibly boring part of checking that stuff still works the same way you expect it to. Not to mention that sometimes manually testing stuff is really hard. So think of the following example: calculating the total price of an order. Sounds simple enough, right? Here's one process how this might work. Calculate the price for each line item, add the line item prices, check for bulk discounts and subtract, redeem any vouchers that the customer might have, reimburse any refunds that they might have from previous orders, add shipping costs, add taxes. Good luck doing that in your head. It's just really, really hard. And more importantly, good luck doing this through the UI at all. There's mind-boggling amount of combinations, of possible combinations in this piece of code alone. And just trying them all through the UI is just going to be next to impossible. There are so many possible combinations here, it just becomes really hard. So the result of that is that once your code is written, it will never be changed. And I think as software developers, this is a problem that we are way too familiar with. We have islands of code which we're like, oh, Peter wrote this a couple of years ago, and then he moved away and started a fish farm business, and no one wants to touch it now because Peter was the only one who understood how this works. And so you have these islands of code that are just no one wants to touch. And I think all of you who've worked with any kind of legacy application, any application where there's parts of it that you haven't written, have come across this problem. And this is what we call legacy code, right? So talking about the design aspect of testing. You've heard this word, right? TDD, test-driven design. And you may have heard this one, behavior-driven design. And what this means is that you use your tests to drive the design of your code. And for this, unit tests are your main weapons. So unit tests are tests where you're testing an isolated piece of code, and you're using these to ensure the quality that you want. And the main thing about unit tests for me is that unit tests force you to structure your code into units, into logical units of separation. And you can use stuff like OOP. And this helps you to kind of think about the overall design of your application, and to break them apart into smaller chunks which you can easier test. So this is what we're talking about when we're saying TDD. It's not necessarily, to me at least, not necessarily the notion that you write the test first. It's that the test dictates the design of your code. And a huge part of that is writing a narrative first, to put on a sort of different thinking hat, and to put yourself in a different mindset, and to just reflect on the behavior you're building. And you can do that at a large scale, just thinking about the feature that you're writing, or you can do that at a small scale, just thinking about one class or one method, and just thinking about what this is supposed to do before you start writing it. So how is this done in practice? Through the really simple loop of red-green refactor. You write a failing test, you make it pass, you refactor. So the red part is kind of obvious, but make sure it fails for the right reason. This is a problem I see, or a mistake I see people do all the time. They will write a test, and they will run it, and it will fail, and they won't even look at the error message. They won't look at what failed, and what failed won't be the first thing they will fix. They will have an idea about how to write the code in their head already, and they just ignore the feedback that the test is giving them. And I think that's a mistake. If you're doing this cycle of red, green, refactor, let the tests guide you. Just look at the error message. What is it trying to tell you? And fix that error message first. If you're writing any code and the error message doesn't change, you've done something wrong. So green, make it pass, right? Write the most minimal implementation you can think of. In this and in this step only, don't be afraid of ugly code. I often, when I'm in this phase of just trying to get to the green light, to just trying to make it pass, I will try to write the ugliest code I can possibly think of, just to make it pass as quickly as possible. And then the most hugely important thing of this is don't skip this step. Don't skip the refactoring, because otherwise you will end up with this huge messy code base. So clean it up. Think about the names of things. Oh, apparently I don't have electricity here. Oh, right, now it works. Extract code into new classes, into new modules, and so on and so forth. Make calculated changes to your code, but don't be afraid of crazy ideas. And in this step, it's really important to not add new functionality. We have this tendency to look at code and think that, oh, in the future, this could possibly need to do something more. We can design this in a way to make it future compatible. I think it's a mistake. Don't future-proof your code. Have you heard this this expression? You ain't gonna need it. Yagni. It's one of my favorite things to keep in mind when you're writing code. Most likely, what you think is going to happen in the future is not going to happen. The future compatibility changes you're making most likely will never happen for real. That stuff that you think is going to be useful in the future is never going to be implemented. There is no future. Your project can and probably will be cancelled tomorrow. No, I'm messing with you guys. Hopefully, who knows? Actually, my project was cancelled a week ago. I felt kind of sad. A really long-running project, and the client just decided to can it from one day to the next. So that stuff happens. That stuff happens. So ensure code quality today, and don't worry so much about the future, because you can always change stuff later. If you've written the code well enough, it should be resistant to change. It should be possible always to change it at a later point. So unit testing. I'm actually not going to talk too much about unit testing Ruby today. I'm assuming that you guys kind of know this already. I saw lots of hands going up before when I asked about testing. And I will be talking a bit about unit testing JavaScript, but we'll get to this later. I really want to talk about end-to-end testing first. I'm just going to grab some. So I'm talking really, really fast. Am I talking too fast? Are you guys understanding what I'm saying? Awesome. Right. Okay. End-to-end testing has way too many names. We call this end-to-end testing, integration tests, acceptance tests, request tests, full stack tests, and there are probably a few other names. If you ask more people, everyone calls this something different. I don't really care what you want to call it as long as you fucking do it. I think this is the easiest to understand form of testing, because this is what you are doing already, only it's automated. If you have a legacy application, I think a lot of people try to retrofit unit tests onto legacy applications, and it becomes incredibly painful and incredibly frustrating because the applications were not written in a way to be testable. And this was what we were saying before about TDD and tests influencing your design. If there are no tests, the tests did not influence the design, and so the application is not written to be testable. And end-to-end tests are kind of like a very brute force, like a giant hammer to take to your application so that you can test whatever it's doing. And in these, I really suggest that you mimic the behavior of an actual user of your application, that you try to think about someone who goes and visits your app and tries to do something. What do they actually do? And you try to capture that in a test. And so I wrote a tool called CAPYBARA. You may have heard about it. It simulates the behavior of a person using a website. And the API looks something like this. You can visit pages, you can fill in fields, you can click links and buttons, you can check for stuff on the page. And in most regards, it tries to sort of capture how a normal person would interact with your website. It doesn't really try to be a simulator of any kind. It just tries to capture behavior. It has the ability to switch seamlessly between different drivers, and with drivers here we mean different ways of exercising your application. So there's Selenium, for example, which launches a browser and which then works against your application. There's CAPYBARA WebKit, which is a completely headless driver, which doesn't open a browser but still uses the WebKit engine to interact with your app. And then there's RACTest, which uses the RAC protocol and is written in pure Ruby. And so you can just run this directly against your Ruby applications, and it's really, really fast. But unfortunately, it doesn't support any JavaScript. So if you want to test any code that uses JavaScript, you're out of luck with RACTest. So let's do this, actually. I don't know how well this is going to work since we're so many people, and the network might be not strong enough. But I'm kind of encouraging you to follow along in doing this. This is supposed to be kind of a class, so if you have a laptop, open it up and try to do the stuff that I'm showing and see how it works out for you. So if you guys could just start off by generating a Rails app, and I'm just going to give you a few minutes to do this, or a minute.
Shut off that light. I don't know if this is helping you or not.
No, it's not helping me at all. Can I turn this off? Is it okay? Yeah. And I've put in the skip test unit because I don't like test unit so much. So we're going to be using RSPEC instead. If you can, use 3.1 or 3.1.1. 3.0 is fine as well. Don't do this with Rails 2.3 if you can help it. All right. So we're going to add RSPEC and CAPYBARA to our GEMFILE, and you should be reasonably familiar with this, I hope. So just add it to or create the test group, because it likely won't be there if you use the skip test unit. So just add this group and add it to your GEMFILE. This is going to be a little manual setup. Are you guys cool with that? Oh yeah. I was kind of afraid of that. All right, keep trying to install it, and I will move to the next slide. Just bundle up and use the RSPEC generator to install RSPEC. RSPEC Rails and CAPYBARA. And make sure to add the require CAPYBARA RSPEC, because otherwise it's not going to work. And if you have any problems, just throw up your hand and ask. All right. Is this working for you guys? No? Yep, sure. Actually, if you, oh, I should do that because I forgot to open it up. I'm just going to open up the repo that these slides are in, so you can actually copy paste the code from the slide, so you don't have to type it off. It's Jonas Nicklas on GitHub, but I think I forgot to unlock the repo. So if I can get the internet to work. Yeah, we're probably like ridiculously hammering the network right now. If you can, by the way, try to installing the pre-release version of Bundler. Just do gem install bundler -- pre, because that might be nicer to the network because it does way less requests. Yeah, it's so much faster. It's crazy. Now, I don't know why they're not releasing the damn thing.
There's a couple aspects, small issues that are critical to certain segments of people. At RubyConf, I was like, we all cornered Cone 2 or whatever, but listen.
Yeah.
Release Bundler 1.1 already.
Yeah. In the meantime, we're all sitting going like, oh, bundle install. Yeah.
The guy who invented reCAPTCHA has a story where he feels really terrible about inventing reCAPTCHA because he's like, so 30 million of them get filled in every day. It takes 30 seconds, so I've wasted like 2 people's lifetimes a day. So what would it be like for Bundler?
It becomes even worse if you convert that amount of time into money. Like take the average consulting rate and multiply it by the time it takes to bundle install for everyone. I think that will be a sizable amount of money. Right. So let's try to move on. And if you guys manage to get that, then all good. Otherwise, it's a shame. Yes, bundle exec rails generate RSPEC install. All right. So create a directory for your specs and spec requests. There's actually a couple of other directories where you could put it as well, but I like spec requests. And use your favorite editor, which of course is Vim, to all right. Death to Emacs. To create your spec file and call it create to do item spec. All right. Now this is kind of longish, so I'm hoping that I can get the Wi-Fi to work so that I can actually open this repo up so that you can copy it. But then again, it's probably going to be hideously slow for you guys as well. Yeah. Sorry? My IP address. It's that's right. I'm mobile. So if you do mobile.local:1990, you might actually be able to see my slides. Can anyone try that? Does that work? Mobile.local. If you guys know Futurama, Mobo's the news speaker who is an evil green alien, so always trying to take over the world. He's hilarious. MORBO. I'm guessing you guys can't read that. Oh, that's the wrong way. What the fuck that was? Mobo. Like that. Mobo.local:1990. Yeah, this is not working great. Have you guys managed to install RSPEC and Rails and have got that running? Yes. All right, cool. You're just going to have to type really, really fast. So the idea of this feature is just that we're visiting a particular page, we're filling in a description, and we're clicking this button create, and then we're checking that it should have this particular selector, walk the dog. Oh, this was very big. All right. So it seems like the internet is not playing nice with us today. I still can't even get at GitHub. So instead, I think I'm just going to show this on my machine. Yeah. I would have preferred for you guys to be able to follow along, but maybe that's not going to be possible. So I'm just going to show it here instead. Can you guys read that? It's a bit. What's that? Like that, right? 8 actually. Yeah. That should be better, right? So we have this feature here, created to do item. And I haven't really done anything else aside from the stuff that I showed you guys on the slide in here. And if I run this now, it's probably going to work because I think I already implemented it in this branch. Yay. Oh, right. Bundle exec, yeah. Just make this a bit smaller maybe, right? It's still readable. That's still okay, right? Cool. And it's hideously slow. All right. So you can see that this ran, and that's because I've already implemented this application. Oh, I'm not running it though. We got to get to the interesting part. Yeah. All right. So I already have this to-dos application, and I can fill stuff in here, and I can click create, and it will add it. And you can see that what I'm doing when I'm testing this manually is the exact same thing that this feature is exercising. I'm visiting the page /to-dos. I'm filling in this description with walk the dog. I can fill in with the same thing. And then I click create, and then I just check that walk the dog is on the page. So I'm testing the application the same way that I would if I were doing this manually. And you might be asking, why not use Cucumber, right? Mostly because I want to show you guys how this works at a low level here, and I think Cucumber tends to abstract that away a little too much. And I also think that Cucumber is not the first thing you should use. I really like Cucumber actually, but you should start using it when you feel the sort of pressing need for it. I don't think it should be your default choice when you're writing acceptance tests. I think your default choice should be to write them by hand. And then once you come up with the problems that Cucumber is trying to solve, at that point it makes sense to switch over and to start using Cucumber. And so I was going to give you time to implement this yourself, the solution to this, which you might not be able to do in case we can't fix the internet. But have you guys got that working? Can you run this feature? No? Oh. I made the lights go out. This is actually very cozy. We should. Does anyone have a guitar? Or maybe like we could set up a bonfire here on the stage, and that would be cool. Can we get the lights back? All right. Cool. All right. Cool. Yeah, that's better. This is really hard to do without internet. All right. The idea that I want to get across to you guys is that if you run this, you will see a failure. You will see that it's trying to visit to-dos, and it will say undefined route get to-dos. And this kind of informs you that you need to add a route. And once you've added the route, it will tell you that there is no to-dos controller. And then you go and add the controller. And then it will tell you that the action index is not defined on that controller. And so you will go and implement the action. And so you can kind of always follow along the error message that this feature is giving you. And just look at the error message and try to make that pass. Right. So if we want to add some JavaScript to this, because the UX of this is kind of terrible, right? We want, I have no idea if this is, I can't even open this up, which is terrible because I can't get at the internet, so you can't really grab the example up. Just going to try with this one again. Yeah, it doesn't work either. Awesome. Right. So your feature would look something like this. Here we have a feature for assigning a task to a particular person. And in the app, this could look something like unfortunately, the repo is not available because I can't get on the internet to make it available. But do you have internet connectivity? Can I use your machine? Okay, you should, if you have internet, you should be able to grab this example app because his machine has internet apparently. Cool. Can you clone that down? Is it working? All right, and what you're going to see is this application where we can assign someone to a particular task or to-do item. So we can pick a person, and we can assign that person, and then that person is assigned to this to-do item. So that's fairly simple. But the UX here isn't really very nice. We don't want to press this assign button every time. And we really want to do this with JavaScript instead. So what we want instead is we want something that looks more like this, right? And it will automatically reload the page. But this is not something we can do without JavaScript. We need to attach an event to this select box, and we need to make it change when we change the selection. So if we look at this feature that we've written for this, it looks like this. Visit the page, fill in the description, click the button create, and then we assign this to a particular person, and then we check that that particular person is assigned. So we do the same thing, but we just drop the click button instruction, and we tell CAPYBARA to use the Selenium driver instead. And so if you can, now that the repo is available, you should be able to copy this code from my slides. It's in the same repo, jnicklas/masterclass. So if you copy that from there, you should be able to copy this code, and you should be able to run it, hopefully. So try that out, see how it goes. Sorry? Is it very slow? All right. Still cloning. Okay. Yeah. Yes, it's on GitHub. jnicklas/masterclass. And I still don't have internet. There we go. Finally. Woo. So this is the repo, and here in the talk section, you should be able to if you go in the CAPYBARA section and you click on Add JavaScript here, you can copy paste the the code. It should be a little easier. All right. Is that working for you guys? Can you run it? Still loading? All right. Yeah. I haven't brought my sword. All right. So you might be asking, this seems very inefficient because in this feature we're still like every time creating a to-do item just to check how we can assign it. And I mean, for such a simple feature, that might be fine. But as we scale up our application, we don't want to do all of our setup through the UI. Our tests will become ridiculously slow. So let's find a better way. Let's create this to-do item through the database directly. And we can do this just by using the normal active record methods, as to-do, create, and pass in the description. And if we visit this page, hopefully this should work, and we should be able to see the to-do item. So if you can, try and run this and see what happens. So this is going to be difficult for you. I'm just going to demonstrate this on my machine here. So if I paste this in here, oh, that got messed up. Oh, wait, I missed something. Right, and I run this, you're going to see is that better? Oh, yeah. There we go. This is on 192, I think. Awesome. Yeah. This is because I haven't written the whole thing here. Never live code, it's a bad idea. And I really didn't want to. But it seems like it's difficult for you guys to run this.
Jonas,
Yep.
I have a secret Wi-Fi for you.
All right.
Can we?
Awesome. I actually think it's working reasonably well now.
No, I didn't. Just.
Sorry, this is really hard to do with so many people. I have no idea how to. Yeah. And you can see that this failed. It can't find this task on this page. And you might be wondering, oh no, what's happening? Why can't we find the task that we created to the database? In order to understand this, you need to understand that Rails uses something called transactional fixtures, which means that every scenario on it block is run in a transaction, in a database transaction. Anything that is outside this transaction won't actually ever see the data that is created inside it. So how come we are outside this transaction? CAPYBARA works the following way, that it has one thread for your Rails application and one thread for CAPYBARA. So the stuff that CAPYBARA does and the stuff that the Rails application does are not run on the same thread. And database connections are not thread safe. So Rails makes sure that different threads have different database connections, and thus they have different transactions. So you cannot see from one transaction into the other. And possible solutions to this are to force the same DB connections for all threads. And this is actually what I usually do, but it's kind of dangerous because you open yourself up to thread safety issues. It's way faster though. So if you're willing to do the trade-off and you understand what it means, then it's a good solution. But instead, you can just truncate the database instead of transactions. And the way you would do this is you would add the database cleaner gem to your application. It's a really simple gem, and the only thing that it does is it just cleans out your database. And you would tell Rails not to use transactional fixtures, and tell database cleaner to use truncation, which means to delete everything, instead of using transactions. And then you just hook this into RSPEC and tell RSPEC to start off database cleaner and to finish it up once it's done. So if we do this and we run it again, we can see that it will be working. So if we go and disable transactional fixtures, and we add this database cleaner gem, and we bundle up, and now we just hook this in here so that before each we start it off, and after each we clean it up, and then we just tell it. Sorry? Oh. Like that? Better? Oh. Yeah, there we go. Thank you. And just set this up to use truncation instead. And so if we run this now, hopefully we should see that it's passing, and that we've managed to remove this transactional fixtures obstacle. Yeah, that dude who made the erroneous commit on 192, which decreased the performance, I think he has also wasted a lot of people's time, a lot of time. So you can see that this is now passing, and that we can now. Actually, I think I'm just going to keep this inverted. Oh, that's not visible at all. All right. Okay. Suggestions for writing your acceptance tests. Always test from the user's perspective. If it's something that the user cannot do or the user cannot see, it's probably not a good fit for an integration test. You probably want something at a lower level, some kind of unit test, in order to exercise this. Remove noise that the user doesn't understand. So anything that that is not immediately apparent to your mom using the application should probably not be in your tests. You can use modules to create your own DSL. If you, for example, have a sign-up process and it looks like this, and you're repeating this all the time over and over again, you could just call a method instead, sign in as Jonas, and you would extract this into a module, and you can just use the normal abstractions you would use in Ruby, you can just use for your tests instead. Also, like I mentioned before, use Cucumber to abstract common patterns. I think it's really, really brilliant at that, and it's widely misunderstood tool. But if you come to a point where you feel that it's really difficult to maintain your test suite because it's just growing too large, I think Cucumber can really help. CAPYBARA selectors are a really cool feature in CAPYBARA, which many people don't know about. A lot of the time you do something like this, where you're doing some kind of complicated selection. In this case, we're trying to find to-do items with a particular name. And writing this out every time gets kind of tiresome. And so CAPYBARA includes a way so that you can write it like this instead, which I think is way cooler. And the way you do this is you just tell CAPYBARA what a to-do item is and what the XPath expression for it should look like. So never assert only assert on visible things, never assert on URLs or cookies or session or application state or anything like that. URLs, I think, is the most common mistake that I see people make, and I think it really makes your tests very, very, very brittle. So I see a lot of people doing, I should be on the X page, and then they map it to asserting that the current URL matches something that you specify. And I really think that's a mistake. You should be, your users don't care about your URLs. They care what they see on the screen. And that's what you should be checking, not the URLs. So avoid tying your tests to your implementation as far as possible. I really hate when people use IDs to select elements. This is kind of, if CAPYBARA was written as a replacement for WebRat. If I had written it from scratch, I wouldn't even have allowed it because I think it's a bad idea. You're exposing a lot of the application's internals by writing something like post user ID. Question? Yes, he was asking about legacy applications where labels are not present. Sometimes you don't have a choice, and in that case you need to do the best you can. If you can, I think you should use labels. If it's not an option, then you need to use something else, obviously. Or maybe try to retrofit the application with labels. It's possible. But I see your point. If you're working with legacy applications, it's you might not have a choice. Yes? He was asking about big tables where there are no labels whatsoever. You can use a lot of tricks. For example, if you have a table, the row that you want to do something with will most likely have some kind of identifying property. So say that you want to delete the item that is called buy milk today from a to-do item. You can target that particular row which contains buy milk today, and then you can find the delete link inside that row. And this allows you to delete something without having an explicit reference to that particular button. And I think it makes sense also from the way that a user would use your application, because they would scan that table for a particular row, and then within that row they will click the button. So it actually makes kind of semantic sense from how a user of your application would interact with it. Does that make sense? All right. So I think you should be as lenient as possible and avoid too specific asserts. Try to not be too picky about what elements there are on the page and what classes they have and stuff like that. Your users probably don't care. And if you really need to test this stuff, you should probably be testing it not in an acceptance test. That kind of stuff belongs in a unit test. So if you're really concerned about the very specific markup of your page, you should be taking that in a unit test. In an acceptance test, I think you should be as lenient as possible. And the idea with everything that I'm saying here is to make your application, to make your test suite rather, resistant to change. So that if you change the internals of your application, you don't have to change your test suite at all. So learn the CAPYBARA API. It's quite well documented and it's quite small. The README, I think, sums up most of the things you need. But I still see a lot of people who don't take the time to read it. So try to understand it. It's really not very hard and it doesn't take you long to learn it. And there's some cool stuff in there. So let's talk a bit about unit testing JavaScript. I think the best framework for unit testing JavaScript out there is Jasmine. It's a really nice testing framework. It's inspired by RSPEC, so it has very similar sort of syntax. So especially if you like RSPEC, you should be very immediately familiar with how things look in Jasmine. It's stable, which is more than you can say for most testing frameworks in JavaScript. And it's quite small. Actually, the code base is not very big, but it has all the features that you need. It even has a test double framework. It's not mocking. It uses something called a SPY, which is similar to mocks. It has it built in, so you don't even need a separate library for that. And its general purpose, you can use it to test everything. But what I found was that it was really hard to get going with testing, with unit testing JavaScript in Rails. I just had this feeling that I want this to be as effortless as possible. And so I wrote this library called Evergreen, which pretty much just packages up Jasmine. So it's not a test framework on its own, but it uses Jasmine and just sort of provides a harness for running your tests in Jasmine. It has no generators, it has no setup at all, and it works great with Rails. And those were sort of my design goals when I was building this. It's not tied to Rails, though. You can integrate this with any rack framework that you want, so you can use it with Sinatra or Padrino or Raptor or Remaze or whatever you want. And it also works really well for testing pure JavaScript. So it doesn't even need a rack application or Ruby at all. You can get really nice syntax via CoffeeScript. Have you guys used CoffeeScript? All right, awesome. I really love CoffeeScript. I think it's a huge change for JavaScript. It's just so much nicer to use and to write than using normal JavaScript. I was writing all the examples that I'm going to show you in a second in plain JavaScript before this presentation, and I was like, oh god, this is so horrible. I wish I could write this in CoffeeScript. So check it out if you haven't yet. It's really awesome. So running your tests with Evergreen is really simple. You can run them in the browser by going to /evergreen. It's a Rails engine, so it just like mounts itself on /evergreen. And the actual Evergreen application is written in Sinatra. You can run it from the command line just by issuing evergreen run. And you can use any CAPYBARA driver you want because it uses CAPYBARA in order to run your JavaScript unit tests. So you can use Selenium or CAPYBARA WebKit or Clarity or whatever you want. Let's try doing this. If you have the application, you can try to follow along. You might need to reset the changes you made previously and check out the client-side branch because it has the code, the sort of base code. And here we've kind of, if I'm just going to do this in the terminal, I need to do this as well. Right. If we look at the application, it's kind of simplified. There's no creation anymore, and the assignment is gone. And in this case, we want to edit to-do items. Where was I? There we go. If you don't have any to-dos, you can run rake seed, and that will give you a list of to-do items that you can play with. And so let's add evergreen to our GEMFILE, and as you can see, we're doing that to the test and development groups, and we're requiring evergreen /Rails. And if I just do that here, I'm just going to invert this again. Right. Add this code. Bundle up. All right. And if you restart your Rails server now, I'm just going to put this up again here so that you can grab it if you want and follow along. If you boot your Rails server now, you should be able to go to localhost 3000 /evergreen. /evergreen. Is it still loading? No, it's working. All right. And you should see something like this. And this is just a sort of